I don't have a nickname, which obviously is a little bit odd for Thai. You can call me Charin. I work as a data scientist. I used to work at some e-commerce called Lazada. I now work at a company called Bridge Asia and does healthcare and medical imaging. Starting from Monday, I'm going to be head of data science at Central. So, thank you. So I'm like kind of in between here. But more importantly, today I'm talking on behalf of an open source project that I have been a part of for about a year and a half, which is pyThaiNLP. So before we go further, let me kind of get a feel of who the audience are, if you may, getting to know each other, you know, people upstairs, hello. Who here have heard of pyThaiNLP? Whoa, guys, what? Guys, you're developers, you don't have to, okay. So cool, so almost everyone knows, my mic is weird. Almost everyone knows what I'm talking about, more or less, right? You know how to do NLP, you know how to do machine learning. Is that correct? It's probably correct. I'm gonna assume that's correct. Okay, so as you've seen in the abstract, today I'm gonna talk about how our very own implementation of text classification called thai2fit outperforms Google model called BERT, right? Has anyone heard of BERT? Do you know what BERT is? Okay, I feel like the people downstairs kind of get, but the people upstairs might not. So BERT is not a Sesame Street character. It's a model for a lot of things, but among them is text classification. And it's obviously a state-of-the-art in a lot of languages, including English and many other languages, but obviously not for Thai. And we're gonna tell you a story. Today I'm gonna tell you a story of how a group of like random people that you see on the screen, some of them missed the photo session, so I just have to Photoshop them in, managed to outperform what Google have done, right? And I'll probably gonna tell you the reason why, I mean, in my opinion, and I hope you enjoy the story. So, first I'm gonna take you back to 2016. 2016, can you imagine 2016? What happened in 2016? World Cup? No, Euro, something like that. I'm not really sure. But the point of 2016 is that Thai NLP is going absolutely nowhere. That's what people talk about. I mean, we don't think so, but a lot of people just saying, Thai NLP, there's no way of doing it for various reasons, which are very valid, but also that's something that we have to deal with. First, the tokenization problem. So I believe most of you speak Thai. For those who don't, we have a really annoying language. Like seriously annoying language. The first thing is, we don't have spaces. We don't have full stops. So you don't know what is a word, what is a sentence, no idea, right? So tokenization is a huge problem, and the way you tokenize it is also very debatable. For example, there's one very famous example where you have the word tak lom and the word tak lom, which spell exactly the same, but if you cut it differently, one means brown eyes, one means taking the breeze, like shilling, something like that, which is totally different things. It's like a verb and a noun, right? So if you cut it the wrong way, you're screwed, right? So basically, it's a very difficult problem. And I think personally, even more than that, is that Thai language has serious ambiguity. So when in English, you know what is a word, right? A word is a word. A sentence is a sentence, you can see. Like a compound sentence, like a simple sentence. So complex sentence, whatever. There's a sentence, then there's a word. But in Thai, I asked everyone from like high school students to professor of literature in Thai, what is a sentence in Thai? Nobody can answer. Nobody has the authority, the absolute authority on pinpointing what is a sentence in Thai. And this is ridiculous when you're trying to do NLP, right? Because, I mean, dude, it's not easy to handle as a human, and it's not easy to handle as a machine. And most importantly, we also have very few data sets, very few sizable data sets. The only big data set we had back then was called BEST. It was released by a company called Nectec, and which is funded by the government. But this is the only sizable data set that they actually release and is usable at that time. So, and it's only one data set for tokenization. So that's the stage of affairs back then, right? Everyone, don't even mention NLP, don't even mention like doing sparse TF-IDF matrix. No one talks about word vector and everything. Everyone was just, we cannot tokenize it. We don't know how it works. And we don't have data to do anything else, right? So everyone was just kind of tackling the tokenization problem. Then this is the commit that changes everything for me. For me, this is the commit that totally changed the history of Thai natural language processing. And I'm not even kidding, right? So, so there's this one kid who's sitting over there. Yeah, guys, he totally deserves all the applause in the world. So he was the one who created the library of pyThaiNLP. By far today is the largest natural language processing library in Thailand. So I asked him, because I asked Ton Tan, was like, dude, I'm gonna give a talk which relates to pyThaiNLP today. Can you tell me how you started the library? And here's his answer. So he told me, well, I was supposed to be studying for the entrance exam because I was last year in high school at that time. But then I just wanted to create a simple chatbot, right? And then I found this library that do proper tokenization, but I don't see anything anywhere near comprehensive as what English or other languages has, like NLTK. So I figured I'll just make one by just compiling a lot of things people have done before. So it's just this. And everything began, right? So how it started is that, so Ton Tan his GitHub handle is Wanapongkom. He started aggregate pre-made language modules like PyICU into pyThaiNLP, just to group things together, basically just to have a structure for everything, right? And then he met this person called Korakot, this guy who's supposed to be here, but probably doing his life now. So Korakot is a veteran researcher who has been working for Thai NLP for a long time. So they talked, and then they create the Thai NLP group on Facebook. So we are now the world's largest group for Thai natural language processing. Possibly the universe. So it started with these two people who work together, and so they create their own version of the tokenization, which is based on a dictionary-based maximal matching algorithm. So no deep learning, not even machine learning. You just have a dictionary there, and it cuts the longest word, for example. And yeah, it's pyThaiNLP kind of gaining steam, and a lot of people are trying to use it. And I mean, it works, right? It kind of works. Then there's me. There's me, person over here. So at that time, I sucked at Thai. I am a Thai, but my favorite language is English. because I totally hate Thai. I cannot speak Thai at work or anything. It's very difficult for me. Knows nothing about NLP because my background is in statistics. I do mostly structured data. I don't have any training about NLP at all. I don't know what, for example, I didn't know what the TF-IDF is. I don't know how it's calculated. But one thing I know, that because I was working at the e-commerce company at that time, one thing I know is that I need to get a job done. And guys, perhaps that's the most, is the strongest motivation anyone can have in the world. So I joined this team. So because I said I want to solve a problem. My problem is, so the company, probably if you heard, anyone here has used Lazada before? Okay, how's your experience? Okay, don't be shy, I don't work there anymore. You can say what you want. No, Lazada is an amazing company, but obviously, as of many e-commerce companies and all companies, we have a lot of customer service messages. Sometimes to say our service is very good. Sometimes a lot of times just to say that it's shit. But well, we need a way to classify these messages and for our customer service rep, not just to look through everything, and it's going to be very labor intensive, right? So I was trying to make this model, and I ran into a problem that there's nothing. PyThaiNLP is the only library that can do that. That come close to doing that, right? So, I start tackling this problem, and to my surprise, not really surprise, but to my confirmation, I found out later that it's the problem that almost everyone was complaining about at that time. That was about 2017, yes. So later we did this poll in the Thai NLP group, and we found that about 90% of the people, when you ask them what use case of NLP you wish exists for Thai language, they would say text classification. And you can see text classification come first, text clustering, okay, fine. Sentiment analysis, which is text classification, guys. Stop calling it sentiment analysis. Please just call it text classification. It's driving me crazy. So basically, it's a huge problem for everyone. So, and at that time, 2017, more or less, the problem of word tokenization has kind of been solved in a way, right? So remember, we have the best corpus from NECTEC, right? And it has about 5 million words. Correct me if I'm wrong, everyone. 5 million, right? And it has its own test set, and people can make models. So a lot of people have tried their hand on using. It's around the time that deep learning is kind of booming, and everyone using convolution and everything. Embeddings, convolution, or embedding LSTM, we're using these things to solve the tokenization problem. And they've done a pretty good job, right? Because you can see DeepCut, which is another student of Fast AI. They're doing 98% accuracy, not accuracy, F1 score, which is basically balanced kind of accuracy, right? And everyone was doing 95%, and it's also seemed very good. It seems like, okay, we're out of this tokenization hellhole, right? But not really, because, okay, and then the new is the pyThaiNLP version that we're using, right? It's only 70% correct, which is not ideal, but we can live with that. The problem is these 99% tokenization, they're very slow, and rightly so, right? Because when you do LSTM, when you have embeddings, you have to go through very many recurrent layers, or even doing convolutions. It's going to take so much time. To give you the big picture, using a dictionary-based new the one that pyThaiNLP and Gorakot implemented, it takes about 5 seconds to cut best. 5 million words, right? But if you use one of the libraries, for example, DeepCut, it's going to take you 2 hours. It's going to take you 2 hours. And that's only 5 million words. And that's ridiculous, right? Because if you have to wait something like this, you can't really implement anything, right? So we made a decision to stick with new MM and try to make it work with only 70% accuracy, right? So this is actually me. I had a hypothesis, right? My hypothesis is that I found this thing called word vector. And I found that, hey, it's a way of transforming your text, your words, your tokens, whatever you call them, into just a numerical vectors, right? And I feel like, hey, maybe this can help if your tokenization is not perfect, right? For example, if taklom and taklom that I showed you, right? Cut one way is noun and adjective. Cut another way, it's verb and noun. So if you do sparse model with this, right? You do backup words or something with this, it's going to be ridiculous. But then, if you approach it like, whatever you cut it, you just change everything into a document vector. So let's say 400 units, 400 items vectors, right? Then maybe, of course, it's going to be different, but maybe some numbers in the 400 numbers can be the numbers like, okay, this number is the probability of you cutting it wrong way, something like that. So I suppose it would help. So I went on and to test the hypothesis. So at the time, enter this incredible gentleman, Jeremy Howard. How many of you have heard of Jeremy Howard? Okay, sizable. You should. If you haven't heard of him, you should look him up. He's the founder and researcher at Fast AI and University of San Francisco, and founder of various startups. So this gentleman has a course that teach people to do deep learning with the motto, make deep learning uncool again, because it should be for everyone, right? So I took one of his courses because I was trying to learn about deep learning and see how it goes. And this very interesting approach in one of his classes, right? So the approach is that you can do transfer learning in NLP also. So I assume that if you're familiar with computer vision and or deep learning, you have heard of transfer learning when you pre-train your ResNet models or your whatever architecture on ImageNet, and then you transfer it to your domain. For example, train on ImageNet and transfer to X-ray images, which is exactly what I do at work. But yeah, so he said, hey, maybe this you can do for text also. So what he did is that I think it's very neat, is just train your model, train a language model on Wikipedia or any super big pile of text. Could be Wikipedia, could be something you scrape from internet, could be OpenCrawl, whatever. And then getting it to familiarize, have a good language model on that kind of pile. And then fine-tune it to your domain-specific data set. For example, in my case, so I trained on Wikipedia, a good language model, and then I fine-tune it on customer service data. And then, after you have that model, you do the same as when you do image classification. You cut the head of the model off, and then you replace it with your classification layers, your sequence-to-sequence layers if you do translation, something like that. So this very simple idea, right, is very powerful, it turns out, right? Oh, actually, wait, I forgot. I forgot to mention what a language model is. I think everyone I don't think everyone knows what a language model is, so I'm just going to explain it here. A language model, when you pre-train this stuff, is just a fancy way of saying the model that fill in the blank, right? So basically what we do in this step, in these two steps, is that we just put the text for the model. Let's say, like, for example, สวัสดีครับพี่น้องเสื้อ and then you can guess, right? I think most of us can guess. Most of us as a human has an idea, right? And we train the model to think the same way as we do, something like that. And we hopefully that layers or in the earlier in the encoding layers that we learn how language works, right? So it can generate like the next word, or it can generate like continuous text based on your input, right? So I have a very fun thing that you can try at home, right? So sorry for people who doesn't speak Thai, but so we have this pre-trained model on Wikipedia that you can access on a collaboratory notebook from this QR code. I haven't thought this through because obviously I don't think you can open collaboratory on your phone. Maybe you can, I'm not sure. Or maybe you can get the URL and open it on your notebook, that'd be fine too. So basically, when you input the seeding words, for example, this I input once upon a time, it can write you a story, right? It can write you a story based on predicting the next word. Right? So, and obviously if you are Thai and you can read this, you can like kind of see this thing it's quite realistic. It's a story about a monk who goes to a king and like having it's a story, and I mean it's quite amazing that computer can do this, right? So at least you can see, you can think that, okay, it has a sense of how language works. It doesn't really make any sense, but I mean, it's kind of like resembles what we think of as a story, right? And like, yeah, it doesn't make sense because in the end, it just say like, Beyonce, something, summer of hard rock, the blue this way, which doesn't have anything to do with the monk, but anyways, yeah. So we kind of train these things. And so my second hypothesis is that, hey, when I see this thing, it kind of makes sense, right? You can treat this as a feature extraction layer, like when you use ResNet or other stuff, right? And I feel like, okay, this transfer learning should work with text as well. So this is me in January 2018, just asking questions on a Fast AI forum that, hey guys, I think the thing that we learn in class, I think it might work. So maybe maybe I'll try do it in Thai, right? So this is what I did. Very early versions, but the structure remains the same throughout all the versions. So first, the pre-processing. Like Thai is a very annoying language, as I said, so we need some kind of special rules. And this is where I say that we cannot do this alone because I don't have any knowledge. And I built so much. I built almost everything upon what Dontan and what Gorakot has done, right? So things like cleaning rules, text normalization. Sometimes when you write Thai language, you put the vowels before the special tone thing, or you put it before and after, and it becomes different words. Or handling words and character repetitions, that we need a special way of handling these things because we don't have a space like in English. So all these things, we really pay attention to pre-processing. The reason is nobody is paying attention for us. In the Fast AI library, they have the very default room, very good rules, but only good for English. And it obviously doesn't really apply to our language. So we spend a lot of time, and I feel that 90% of our value come from these steps. Then we do the pre-training. So this is basically very standard way that Fast AI was teaching me how to do. trained on Wikipedia dump, about 40 million words, which, do you think 40 million words is a lot? Who thinks 40 million words is a lot? Who thinks it's not a lot? Okay, I'm not sure about the people who didn't raise their hand, but but yeah, I mean, 40 million, it's okay, it's sizable, right? And so then we did the fine tuning. Basically, you train the language model. If you look back at the story, right, the story kind of makes sense, but what have you guys noticed? I think one thing that I noticed is that the language sounds like an encyclopedia. And it makes sense because the model learns from an encyclopedia. So it speaks like an encyclopedia. So we need this fine-tuning step. For example, okay, this guy speaks like an encyclopedia, and then I teach them how to speak like customer service messages, right? So basically, this is the fine-tuning. Then we do what the diagrams show you. So we cut off the fill in the blank layer, and we replace it with the classification layer, right? So basically, that's all we did. And I mean, what do you know? You have state-of-the-art classification model. At that time, the only international benchmark we had was comparing it with Facebook fast text. Fast text is, at that time, the state-of-the-art for short text classification. And all our benchmarks are actually not very long text. Wong Nai, do you know? Everyone should know Wong Nai. It's a kind of Yelp of Thailand. So restaurant reviews have 5 class, 1 to 5 stars. So we actually outperform a lot of people. Like we outperform fast text in more than like 20%. Fast text is like 0.5, we have 0.6. Prachathai is the t-shirt I'm wearing, is a news organization in Thailand. So we did a 12 label news classification with their data. And we also outperform like linear SBC is a sparse model, and fast text, we outperform them by quite a lot, even more than Wong Nai. Yside is a social media company, and they provide social media data that classify into positive, negative, neutral, and question. So 4 class. We also outperform them. We outperform fast text a little bit, but we did not outperform. We did outperform logistic regression and linear SBC, but not by much. And this also is an issue that maybe we want to tackle, and we want to know why. I think knowing why it doesn't perform as good as it should it is a good thing, right? We did a good thing, and then around the same time, January 2018, this thing called ULM Fit came up. So Jeremy said, oh, the thing I taught you in class, actually I wrote a paper about it, it's called URM Fit. So I was like, okay, cool, then let's call it URM Fit also, right? So after 1 year later, in 2019, I think, we asked the same questions again in our group, like, so what is your problem about Thai NLP? Turns out people were saying, so text classification is still the 4th place, but not everyone was asking for text classification anymore, right? And when they ask for text classification in 4th place, they're asking, I need more data set to benchmark. So this for me is a huge win for us, right? Because we take everyone from, how do I cut the words, to, I don't know how to do text classification, to, I know how to do text classification, just give me more data sets. That's exactly what we did, right? So we talked to many companies, and a lot of credits, almost all the credits go to Ajahn Ekapon of Jula, who just negotiate with Wong Nai and Yside and True Voice for them to release the data. Props on all these companies, bless their heart. And we have a very kind of varied data set to benchmark text classification now. Right, and then 2018, as you know, BERT released that model, English state of the art, amazing architecture does not work in Thai. Right? You can see BERT performing like almost as good, which is ridiculous, considering it should not be this bad. When I first saw this, I don't believe it. I didn't believe it. It's ridiculous. It cannot be this bad. So I was thinking that what might be the reason that it's not performing as good as it should. A few reasons that first, pre-processing. BERT is using sentence piece, which means that it's using tokenization that doesn't perform very well, has been proven not to perform very well in Thai. The pre-training takes extremely long, and it's very resource consuming. So you can only do max sequence length of 128 words, which is not the best way if you guys know about transformer. Transformer needs to train with a very long sequence, like 500 or 1,000. And this is probably another reason that it's not very good. And last one, I'm not sure. It may be because our training data is too small. When I ask, is 40 million words is a lot, it's actually not a lot at all, right? So these may be the reasons. So, but actually, about last month, someone finally, after 2018, someone finally outperformed us, 2.5 years. And they outperform us not by superior architecture. They're using exactly the same architecture as we do. They just pre-train on 120 million words, so 5 times. And they have their own pre-processing rule, which is interesting. And they also use the same model, right? So this is by a student, undergrad student in Chula called Thanapat. And the group of students, they just like, hey, I'm just going to scrape all social media and just pre-train it on a 5 times corpus, larger corpus than you. I'm going to outperform you. And they actually did. And when I first saw this in the group, I was thrilled because for a year and a half, I was the only one working on this text classification thing. And it's ridiculous. And I'm really happy that someone finally just made a dent, right? So lesson learned is that there are 3 things. First, we're not prioritized, and we need to understand that, right? Google and Facebook researchers, of course, they look at this, they see BERT is, they understand. They're much smarter people than we are, right? But we are just not prioritized as a market. And that's a fact, right? And the second one is our community is amazing because we start out with a high school student. We got help from veteran research and an NLP noob like me. Then we got outperformed not by Google or Facebook, but by undergraduate students. This is one of the most exciting things, I think, about Thai NLP, right? And, but then we still have a problem of data sets that is a rarity, right? So that's what we're trying to solve. And here's our new team that we have a lot of people joining us in 2019. And we have allies in Vistech, an institution that is going to invest like I think at least 40 million baht to create these kind of data sets and open it to the public as a part of pyThaiNLP. So I think this is very great time for Thai NLP. And if you guys want to help, I hope you guys do. So I thought of 3 easy ways that you can try to help is that first, contribute with codes, documentation, tutorial, just test our bug, very standard stuff. Help us crowdsource the data sets in Xiaomi's AI with Vistech. Or just simply create more open source text, right? Just write more Wikipedia. For example, we have 40,000 articles, guys. English has 2.5 million. Vietnam has 60,000 articles. Indonesia, 90,000 articles. What's 40,000? Are we ridiculous? Right? Just write more articles. Something like this. You don't even need to code. There's a lot of ways you can contribute. And I hope that, I hope that it was an interesting story and useful story for you guys. You have any question, there's the links that you can go. And thank you very much.